everyone, welcome back to today's lesson on our essential question of what is theoretical probability. So that word theoretical is kind of a challenging word to say, so practice saying it. Theoretical probability. It builds off experimental probability. So yesterday in our last lesson, we looked at experimental probability being based on repeated trials of an experiment, where the event was a fraction that we created with the number of times the event occurs over the total trials. We're going to be making another fraction today, but theoretical probability is a fraction of favorable outcomes over possible outcomes. So we're going to have to look back and remind ourselves what favorable outcomes are, just so that way we remember what that is. So theoretical probability, let's go ahead and write out our definition for today. Theoretical probability is the quotient, quotient is dividing, quotient of the number of favorable outcomes and possible outcomes. Okay, so theoretical probability, the biggest thing here is quotient. So we're going to make a fraction and then we're going to use it to divide favorable outcomes and possible outcomes. So P is the event, and then our P of whatever the event is equals this fraction, number of favorable outcomes over the number of possible outcomes. All right, so we're going to go ahead and remind ourselves what are favorable outcomes. So let's look back in our notes to favorable outcomes. Favorable outcomes are the outcomes of the specific event. So whatever the outcomes could be for the specific event. And we know an outcome is the result of the experiment. So we're looking at the results of an experiment for the specific event. So we're going to combine those two things together. So let's go ahead and look at an example so we can see this in action. So the event that we're looking at is the experiment is randomly choosing one letter. The event is choosing a vowel. So how many times could you choose a vowel from the pile? So let's look at example 1. Says randomly choosing one of the letters. What is the theoretical probability of making a vowel. Okay, let's look. We have an E, and we have an X. They have another tile that has an L, one that is a P, one that's an O, another E, and an R. Okay, so we're going to create this fraction here, and then we're going to figure out what the probability is of choosing a vowel. So we could choose this E here, we could choose this E, and we could choose this O. So there are 3 vowels that we could choose. 3 vowels out of 1, 2, 3, 4, 5, 6, 7 tiles out of 7 tiles. So 3 out of 7. Randomly choosing one of the letters that is a vowel is 3 out of 7 tiles. So we're going to look and see how do we make this into a percentage. So we're going to take 3 divided by 7. 3 divided by 7 gives us 3 divided by 7. Quotient is 4.428, or we're just going to round up to 0.43, or move our decimal point over twice, 43%. So you have a 43% chance of choosing a vowel, a 43% chance. Almost 50%, but it's a 43% chance. Okay, let's do another example of theoretical probability. So, theoretical probability of the letters. Okay, so we're gonna look at a word, and we're gonna have all of them, and we want to choose a letter from the hat that is a vowel. Okay, so number 2, we have the letters from the word Jackson put into a hat. Okay, so these letters are put into a hat, and we want to know, you randomly choose a letter. What is the probability of choosing a vowel? So we have another vowel situation here. Okay, so again, we're going to look and see how many vowels are in the word Jackson. So this is a vowel, the A and the O. So we have 2 vowels out of 1, 2, 3, 4, 5, 6, 7. Why did they do 7 again? Okay, so 2 out of 7 total letters. 7 letters total. Again, we're just going to now use division. We're going to do 2 divided by 7. 2 divided by 7. And that's going to give us a decimal. So let's do it. 2 divided by 7. This gives us a decimal of 0.285. 5 tells the 8 to round up, so we're going to say 0.29, or 29%. 29%. So the theoretical probability of choosing a vowel is 29%. Okay, it is your turn now to do a try it. And we are going to, I'm going to see if I can find one that uses like a spinner or something like that. So it's just a little bit different. Please hold. All right, your try it for today. Here are our try its. Number 1, you have a spinner that looks like this. So here's the middle. It has 5 equal parts to it. And in the equal parts, there's a 10, a 2, a 4, a 6, and an 8. And they want to know what is the theoretical probability of spinning an odd number. Ooh, this one's tricky. What's the theoretical probability of spinning an odd number? And then number 2, it says that 5 students own smartphones. 11 students do not. What is the theoretical probability that a randomly chosen student owns a smartphone? You randomly choose a student who owns a smartphone. All right, go ahead now and hit pause so that you don't hear me solving these problems and so that you can check your level of it. So solve them yourself and then come back and check your level of understanding. So number 1, spinning an odd number. Number 2, randomly choosing a student who owns a smartphone. Okay, go ahead and hit pause right now so you don't hear me solving, and then come on back when you're ready. Okay, so we're going to make a fraction on the first one. Odd numbers. There are no odd numbers, so 0 odds. And out of 1, 2, 3, 4, 5 total spin outcomes. So there is a 0% chance of spinning an odd number. A 0% chance of spinning an odd number. You just can't do it. This one is completely and totally unlikely. It's not possible. Okay, number 2. Number 2. 5, oh my goodness, Miss Englander. 5 students own smartphones, 11 do not. So we want to choose a student who owns a smartphone. So there are 5 students who own, 5 own out of the total number. So we needed to add these. 5 plus 11 gives us 16 total students. So now we're going to do 5 divided by 16. So 5 divided by 16, this is going to give us our probability. 5 divided by 16, and this equals 31. So this equals 0.31 because the 2 tells us to stay the same. So 31 or 31%. How did you do on these 2 try-its? How did you do on your try-its? Go ahead now and answer your essential question. How do we find the theoretical probability And then put your level of understanding out to the side. Where are you at with understanding? Can you find the part that they're looking for out of the total? Can you divide? Can you turn it into a percentage? Where are you at with creating a fraction, dividing, and making a percent? Where are you at with that? And then when you are finished, you can come on back to the Google Meet and ask for help, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.